Welcome back, everyone. Okay, the second video is going to cover the law of cosines. The first video covered the law of sines. And if you take a look at the equations, these three equations represent the law of cosines. Yeah, you want to take a minute, you want to pause the video and write those in your notebook. Now, they do look a little more complicated. They look more complicated than the law of sines. And our purpose in Algebra 2 is not to develop where these came from, although your book does have a good proof of it. But your trigonometry course or your pre-calculus course will spend more time on where these equations come from. For Algebra 2, we're just going to use them and we're going to try to apply them into word problems. Okay, if you look at the equations themselves, they kind of look familiar. In fact, it looks like it's the Pythagorean theorem is part of it, and then something else is being added to it. And they are derived from the Pythagorean theorem. And what you want to do is, to help you remember, just take a look at the last one here. C squared equals a squared plus b squared. That is the Pythagorean theorem. And then the only thing we're doing to it is we're subtracting minus twice, and then see how this is a squared and b squared? We're subtracting the side, ab again, so minus twice ab, and then we're taking the cosine of c, angle c. Now, don't confuse that with side c. Lowercase letters are used for the sides, capital letters are used for the angles. So it looks like we're taking the two sides, so we have the one side out front, the other two sides are on the right side, and then they're the two sides again, the same two sides. Sometimes they're being squared, sometimes they're not. And then you're finding the cosine of the first one. So if you take a look at the second equation, you can see that the b squared is on the outside, so that's why it's going to be the cosine of the angle b. The other two are a squared and c squared, and you see minus twice ac. So just a way to help you remember them a little bit. They do look a little more complicated than they need to be, but let's move on and see how they're set up, and then we'll get into some applications. What this calculation shows down here is we're just trying to confirm that this relationship does hold up. And it's using the triangle above, and the triangle is the same triangle I gave you for the law of sines. And the only thing I'm doing differently is instead of applying the law of sines, I'm applying the law of cosines. So for example, the first one, I'm finding a squared. I'm finding side A. Here's side A. There it is. And I'm taking that 9 centimeters. I'm going to square it. So 9 squared gives me the 81.24 square centimeters. That takes care of the a squared. Now on the right side of the equation, it's b squared plus c squared minus the rest of it. So that's what I'm going to do here. I'm going to pick up the 14.8 squared. I'm going to add it to the 8.9 squared. I'm going to subtract it twice. B, which is going to be the 14.8 times 8.9, and I'm going to do the cosine of angle A, which is 34.8 degrees. And that's where these calculations come from. This is just to show you that the law of cosines does hold up. And if we want to see the other two versions, so that was the a squared version, the b squared version, sure enough, there it is, just using the different sides. And this one's using the cosine of angle B instead of the cosine of angle A in the first one. And finally, the last one would use angle C to represent the cosine of angle C. And you can see that the left side of the equation equals the right. The left side equals the right. The c squared equals the right side. All right, and that just proves to us that the law of cosines does hold up no matter how big or how small the triangle is. You'll see that the law of cosines holds up no matter what. Even in our special case, if I can make this as close to 90 as I can get it, let's see if I can get pretty close here, 90 point, there we go, that's perfect. So even if I make a right triangle out of it where I can normally use the ratios, well, you can see even the law of cosines would hold up under these relationships, which is nice. So it applies no matter what kind of triangle you have. Alright, so that's an overview of the equations themselves. This is going to make a lot more sense to you when we start using them in word problems. So let's move on to a word problem. You're going to see how you're going to use the equations. Really what Algebra 2 is about is just using the equation in a problem. So there's two situations you're going to use the law of cosines in. The first situation is when you are given the side, you're given two sides, and you're given an angle. Now if you look at this picture, it should look very familiar from the first video. It's the same picture. The only thing I've done is I've changed the situation so we still know one side is 1,000 meters. And this time we only know one of the angles. And I'm going to tell you angle B is 70 degrees. And we're given that one other side of the triangle is 825 meters. So in this problem, they gave us one of the sides, they gave us the angle that's in between the sides, and they gave us a second side. So they gave us side, angle, side. Side, angle, side is one situation where you want to use the law of cosines. The other situation is side, side, side. Anything else, you're going to use the law of sines because you'll know two angles. So when you only know one angle, really that's really what it comes down to. If you know one angle or no angles, then you're going to use the law of cosines. If you know two angles, then you're probably going to end up using the law of sines. Excuse me. All right, so let's see how we're going to solve this problem. In this problem, we know two sides and the in-between angle. We're trying to figure out how long the bridge is. We're trying to figure out that bridge problem again. This time we know one of the two of the sides. So if you look up here, there's three versions of the equation. The first question you have to answer is, which equation do I use to solve this problem? I can't use right triangle trigonometry because it's not a right triangle, so I can't use the SOHCAHTOA. So it's either law of sines or law of cosines to solve the problem. Well, if I look at this, I only have one angle, so the law of sines is out. That means law of cosines is left. So I'm trying to figure out this side right here, and the side is opposite side angle B. Sorry, the bridge is opposite angle B. So this would be side B. Little b equals the bridge. So we're really looking for B. That tells you which version to use. If you're looking for B, you're not going to use the first one because that's a squared, and you're not going to use the last one because that's c squared. You really want the middle equation, the b squared equation, because you're trying to solve for B. So after you've identified which equation to use, now it's time to plug in the numbers. So all I did here was I took b squared is what we're looking for. That's the bridge side. The other two sides would be 825. I'm going to square it. That's what the formula tells me. The 1,000, going to square that, minus the 2. Now you notice the 825 is being used again. This time it's not being squared. The 1,000 is being used again because that's the AC part of the formula. And then I'm taking the cosine of the angle I know, in this case 70 degrees. That's how you set up the law of cosines. And that's how we're going to use it to solve for the unknown side of the triangle. So the rest is just really number crunching. Now, the arithmetic is not as easy as it may look. A lot of mistakes are made on trying to solve for B. So let me take this slowly. Here's what I strongly recommend. The first thing you should do is do the arithmetic in separate steps. Take the 825 squared and add that to 1,000 squared. So on your graphing calculator, all you need to do is take the 825, you're going to square it, and then you're going to add the 1,000 squared to it, get that little answer, and record that answer. Take the 1,680,625, record that one little step in your equation. And so you end up with the next line that looks like this. The second part of this is I multiplied, I just took the 825 squared plus the 1,000 squared, and then I took 2 times 825 times 1,000. I don't want to do the trigonometry yet. So on the other part, I took the 2 times 825 times 1,000. That gave me the 1,650,000. That's where this number comes from. And then times the cosine of 70 degrees. Strongly recommend doing this. It's going to make your life a lot easier. Alright, now it's very tempting to put together these two large numbers, the 1,680,625 with the 1,650,000. Don't do that. Order of operation tells you that you have to do the multiplication first. So your next step would be very carefully use your graphing calculator. And what you want to do now is type in that first number. 625 minus the 1,650,000. 1, 2, 3. Now you're going to take the cosine of 70 degrees. And before you press enter, make sure your calculator is in degree mode. So once again, go up to the mode button, press mode. Just double check, make sure that that says degrees, because if you're in radians you're going to get an answer that doesn't make any sense. So you want to be in degree mode. I am, so I can go ahead and press enter. And this answer comes out to be a very large number, 1,116,291. Clearly that can't be the bridge, and it's not. This represents b squared. To figure out how long the bridge is, you have one more step, the square root of this number, and there we go. And the bridge is about 1,057 meters, we'll call it, 1,057 meters. And if you remember from the law of sines, the law of sines actually came out. That was the approximate answer for the bridge that we figured out using the law of sines when we knew two of the angles. So it's comforting to know that you're going to get the same answer using the law of cosines. Okay, so now that takes care of this problem. I'm going to pause the video here. I want to give you another word problem on law of cosines. In the second word problem, we're going to use side, side, side to figure out the missing angle. So that's next. That's the next video.